Hey guys, today I'm going to teach you how to do some problem solving with surface area. By the end of this lesson, you'll be able to apply what you know about surface area to multi-step real world examples. So go ahead and get your binder, turn to the math section, and get ready to take some notes. So like I said, surface area can be used to solve multi-step problems. Let's look at our first example. We're at a cereal box company or a factory, and the cereal box at the right is made out of a piece of cardboard that measures 600 square inches. So what they're doing is taking one big 600 square inch piece of cardboard and they're cutting cereal boxes from it. This one was one of them that was cut from it. But we were wanting to know how many cereal boxes can we cut from this big piece of cardboard. Take a second and think about everything you know just from that word problem in this picture, write it in this I know box, and then press play whenever you're ready to check. All right, so there's two big things you want to know from this problem. One is that this is a rectangular prism. It has dimensions of 2 as the width, 8 as the length, and 12 as the height. There's a total of 600 square inches to cut from. That's given to us in the problem. And what we need to know is how many boxes can be cut from the piece of cardboard. So there's a couple of clues here that tell you that you're going to need to use area without it explicitly saying you need to find the area. One of them is square inches. When you're looking at square inches, it's a problem about area. Also, this is the area of a 3D figure because you're going to need to find the area of all the faces to figure out how much cardboard in total you'll need. So this is a problem about surface area. That'll be the first thing that I want to do. So take a second and I want you to find out what is the area of all of the faces, the sides, the front and the back, and then the top and the bottom. See if you can figure out what those areas are and then press play when you're ready to check. All right, so these are the dimensions of the sides, the top and the bottom, and the front and the back. Now you want to multiply these because that's how you find area of a rectangle, length times width. And since there's two sides for every 3D rectangular prism, I want to double each of these numbers. So I'm going to go ahead and do that now. You could also do it at the very end. I'm going to write the 2 on the outside of the parentheses. I don't need to add these up to find the surface area, and I'm going to multiply that 2 and distribute it to each of these terms on the inside. When I do that, I get 48 plus 32 plus 192, which gives me a sum of 272 square inches, and that's my total surface area. So there's multiple ways you could have done that, but you should have landed on 272. Now, the question was asking how many boxes can be cut from a piece of cardboard. So it's important to remember what you need to know, what the question's asking, because you might have done all that work and thought, oh, I'm done. You're not done until you figure out how many pieces of cardboard can we cut from the 600 square inch big piece to make these 272 square inch cereal boxes. So if you figure that out right now and then press play and ready to check. All right, so you should see that you can cut 2 entire boxes from that giant 600 square inch cardboard piece. I know that because I can take the surface area of one cereal box and double it and get 544 square inches. But I can't make 3 because after that, I would have more than 600. I don't have that much cardboard in total. So at that point, you need a new sheet of cardboard. So this is my final answer. Let's skip number 2 for now. You're welcome to try it on your own, but it is a really difficult problem. And let's just go on to number 3 to work out together. It says a shoebox is covered with packing paper. When any 3D object is covered with something, that's going to clue you in that this is a question about surface area. And that's before being shipped. When you ship it, it costs 1 cent or $0.01. Remember, that's 1/100th, so 1 cent per square inch. Again, square inches is another clue. This is a problem about area. How much will it cost to cover 3 pairs of shoes? So take a second, pause the video, and write down everything you know about this problem from the picture and from the word problem into this I know box. Press play when you're ready to check. So I know that I have a unit rate in the problem. The paper costs 1 cent per 1 square inch. So that's the rate that it costs per one thing, which makes it a unit rate. I know this is a rectangular prism because it's got rectangular sides or faces on this 3D shape, and it's a 16 by 10 by 8. Now what I need to know is the last sentence of the question. How much will it cost to cover 3 pairs of shoes? So we're going to have to start by figuring out how much it costs to cover 1 pair of shoes. Then we'll worry about the cost and everything else. So the very first step is going to be to find the surface area of this rectangular prism. So pause the video now, try to find the surface area of this rectangular prism, and then press play when you're ready to check. All right, so you can see that I pulled these dimensions from the color-coded parts of this rectangular prism. So like the green face is the top and it's the bottom. It's the 16 length by a 10 width. Same for the rectangle that's red. It's an 8 by 10, and then the blue is an 8 by 16, and these are the front and the back. So take a second, multiply these out if you haven't already, and see what the area is for one side. Press play when you're ready to check. You should got 128, 80, and 160, and I put square inches because I'm talking about area now that I've multiplied. That's how much packing paper I can cover each side with. Again, these are just the front, the side, and the top. To get the other sides, I can just multiply these by 2 since they're congruent. So again, I'm going to use the distributive property. I know that I can multiply the whole thing by 2 after I add each one of these up. So you can add it all up, and then you can multiply by 2. You can multiply each one by 2, and then add. It is totally up to you. But go ahead and do that now, and then press play when you're ready to check. All right, so you should have gotten a total surface area of 736 square inches. That's how much wrapping paper it takes to cover one box. The question is asking about cost. It's asking how much does it cost to cover 3 pairs of shoes or 3 boxes. This is how much it costs to cover one box. So using 1 cent per square inch as your unit rate, multiply that by 736 square inches and see how much it costs to cover one box. Press play when you're ready to check. All right, you should have realized that it costs $7.36 to cover one box. Now we need to know how much it costs to cover 3 boxes. So this is another unit rate now that it's per one box. So I'm going to set this up as a proportion and show you how to solve it that way. You also know that you can just multiply that by 3. This is how this would be set up as a proportion. It's $7.36 per one box. So we want to know how much it costs X per 3 boxes. When you do this, if you cross multiplied, you would end up with 22.08, and then you would divide by the number that's left outside the circle, which is 1. Anything divided by 1 is just itself. So you'd end up with a final answer of $22.08 to cover 3 pairs of shoes. Number 4 is probably the hardest problem that you'll see with surface area because this is a compound 3D figure. It's made up of 2 rectangular prisms. So the first step would be to decompose the shape into the 2 rectangular prisms and then find your missing lengths and widths that aren't given to you, like here, for example. So you can try this one by yourself. If you have an answer, you can let me know and I will check it for you. But we are not going to cover that in this video. It is a challenge problem. All right, guys, that's it. If you hit the end of this video, please put in the comments, what do you think are the best kind of shoes? I really like a white tennis shoe. I don't really care about the brand. Today we learned all about problem solving with surface area. So now you should be able to apply surface area knowledge to some multi-step real-world problems. And I really want you to focus on thinking of that strategy, what you know, what you need to know, doing your plan and your work, and then coming up with a final solution and writing in a complete sentence. Now you should go back to the calendar and finish any other assignments you have left for the day. Let me know if you have any questions. Bye.